Today I want to talk about the difference of pressure on the head and the tip of the nail. All of you know that the area of the tip of nail is very less, but the area of the head of the nail is comparatively very high. And when we hammer it with the help of a hammer, if we hammer its head, then the force applied on the head creates pressure on the head, and the same force creates the pressure at its tip. Now, I'm going to find out the difference of pressure on head and on the tip. Okay, I want to find out this difference in terms of a numerical problem. And look at this problem. The problem is compare the pressure exerted by a nail tip with 0.1 millimeter square if its area is 0.1 millimeter square, the tip is very less, and if its head with 0.5 centimeter square is hammered with a force 4 Newton. Now we have two distinct cases. One is what? One is pressure at the head. Pressure at the head Now we are talking about the pressure at the head, and another point, pressure at the tip. Pressure at the tip of the nail. Now let's calculate. Now how do we calculate this? First, force on the head is 4 Newton, and the area of the head, it is given 0.5 centimeter square. Now we are going to calculate pressure at the head is equal to what? Okay, we have the equation, that is P equal to F by A. Now value of force is 4 Newton, but value of area is 0.5 centimeter square. Now I want to say something at this place. If force is measured in Newton, then area should be measured in meter square, because Newton by meter square becomes Pascal, that is the unit of pressure. That's why we have to convert this 0.5 centimeter square into meter square. Now how do we convert? For this conversion, we have to remember something. 4 Newton remains same. We have to remember something. 1 meter is equal to 100 centimeter. We know this. And that's why if we have to convert centimeter into meter, then small quantity has to be converted to bigger quantity, centimeter into meter. And that's why we have to divide with the relation. If a smaller quantity has to be converted into bigger quantity, then we divide the number with the relation. That's why we have to divide this 0.5 by what? 100. But not only once, we have to divide twice. Why? When we divide it with 100, then one of the centimeter converts to meter. And again, if we divide by another 100, then second centimeter also converts to meter. Then we will be able to write here meter square. This is the conversion. Okay, let's continue. Simple simplification. This 4 Newton is at the upper side, and this if it goes up, then 100 into 100, and in denominator we have what? 0.5 meter square. Now this is equal to 4 multiplied by 100 into 100 means we can simply write 4 having 40. You can try with the calculator also. This much Newton. And look at the denominator side, 0.5. We can do this very easily. If point is shifted to right hand side, one digit right hand side, then we can multiply numerator with 10. That's why if multiplied with 10, it means simply if one extra zero is placed here, then we can shift this point to right hand side. It means in denominator we have now 5, not 0.5, and 5 meters square, isn't it? And this is equal to what? 5 ones are 5, 5 eights are 40. 8 having how many zeros? 4 zero. 1, 2, 3, 4. Yeah, that's why this is 80,000 Newton per meter square, means Pascal. Normally a big number is represented in terms of power of 10. That's why you can write P is equal to 8 multiplied by, if there are 4 0, 10 to the power 4 Pascal, because 8 into 10 power 4 is equal to 80,000. This way we can solve this numerical. Pressure at the head is how much? 80,000 Pascal. Now let's go to right hand side. Now I want to solve another problem here. Here force is again 4 Newton. There is no doubt. And area is given. Area is very less, that is 0.1 millimeter square. Yeah. Now we are going to calculate pressure at the tip of the nail. This is what? Now we can see we have the same formula, whether it is at the tip or at the head. The pressure is equal to force by area. Pressure at the tip is equal to force by area. Now this is equal to, force remains same, 4 Newton, but area is how much? 0.1 millimeter square. At this point, now again I want to mention that Newton per square meter becomes Pascal. We are going to express pressure in Pascal, but here not meter square, millimeter square. That's why we have to convert this millimeter square into what? Meter square. How can we convert? We must know the relationship. 1 meter is equal to 100 centimeter. All of we know this. And here it is a case of millimeter, not centimeter. That's why 1 centimeter is equal to 10 millimeter. 10 millimeter. It means 1 meter is equal to 100 into 10, 1000 millimeter. That's why what is the relationship between meter and millimeter? 1 meter equal to 1000 millimeter. Now if we have to convert this small quantity millimeter into meter, then we have to divide it with what? This 1000. That's why I'm going to divide this. There is 4 Newton in numerator, and in denominator 0.1 has to be divided with what? 1000. But not only once, because when once it is divided by this 1000, then one of the millimeter converts to meter. But if it is again divided by this 1000, then another millimeter also converts to meter, and we'll be able to write here meter square. So this is equal to 4 Newton in denominator, and this 1000 in 1000 goes up. We can write this 1000 into 1000, and divided by we have 0.1. This is meter square. Now what happened? 4 having 6 zeros. If 4 is multiplied with 1000, again 1000, then 4 having 1, 2, 3 0 here, 3 0 here, 1, 2, 3. Now this much Newton. But do you know that this point is, if shifted right hand side, one digit right hand side, what I told you here, the same here, if shifted to right hand side, we have to multiply this with 10. It means if 10 multiplies this quantity, simply if we put 0, then this point is shifted to right hand side. But now what remained in this denominator? Just 1 only left in denominator. Then I'm not writing anything. I mean to say, I'm not writing 1 in denominator, because this number divided by 1 becomes the same number. That's why should we write 1? So This is the number, final number, and unit is Newton in numerator and meter square in denominator. Only meter square is left in denominator. It means 4 having how many zeros? 7 zeros. 4 having 7 zero means 4 crore Newton per meter square. It means 4 crore. How many zeros? 7 zero Newton per meter square, 4 crore Pascal. Therefore, if the big number comes in numerical problem, then we have to express it in terms of power of 10. This is equal to pressure at the tip is equal to 4 multiplied by how many zeros? 7 zero. That's why 10 to the power 7 Pascal. This is our answer. Now we can compare this. Pressure at the head is how much? 80,000 Pascal, but pressure at the tip is very high, that is 4 crore Pascal. And why this happened with the same force? Because if the same force is acting through large surface area, pressure will be less, 80,000 Pascal here. And if same force is applied through very small surface area, from the tip of the nail, then pressure will be very high. Pressure is inversely proportional to area. This conclusion also comes after the solution of this numerical problem. Okay, this much for today. We'll meet in another class also.